Somebody just, every time I say let's just start, somebody crawls in. Okay, I'm going to pretend it's 9 o'clock. Quick show of hands. How many people have actually used scalar utils, list utils, more utils? A lot of people. Okay. Now I got to remember what these say. So anyway, these things, scalar and list utils started this whole thing out. They were some of the first XS process modules ever written by the famed prophet of Bar in 1997. In 5.005.03, when the stuff was just barely stable enough to stay up. And what's interesting about these is when Perl 5 started out, everyone says, great, we got this new Perl, we got references, we got this and that. And there were still things people did. People always want one more thing. So there were a number of features that weren't in Perl. And Graham Barr sat down and found some really nice, elegant ways to implement what people needed at the time. Later on, More Utils basically added a kitchen sink of pretty much anything you'd ever want to do with an index to the list family. And as I point out here, people here have heard the old line, someone asked Larry Wall, what's the sound of Perl? He said, it's the sound of a wall you're not banging your head against. These utilities, and CPAN in general, but these utilities are a great example of, lazy wheels. This is a wheel we didn't have to reinvent to get where we're going. And they allow you to really focus on what you're doing, not the guts of Perl. So in more recent versions of Perl, 5.10, we have smart matching. There are other things people say, but one of the first comparisons of the smart match operator was comparing the amount of time it took first or a smart match to detect things. And people said, oh, good, smart matches are faster. We can do away with first. And they were wrong because there's some neat things that first still does that you can't get out of a smart match. So the other interesting thing is a lot of these utilities work very nicely with the newer features in Perl. And that's kind of a testament to how well Perl works, because this stuff that was written a long time ago now is still perfectly relevant. The guts of Perl have been maintained well enough that these things can still function. So, starting with scalar utils, this gives you introspection for scalars, no surprise. The kind of questions you can ask here, is a file handle open? These can be used on sockets, file handles, terminals. Did your terminal session vanish? You can check a lot of things about a scalar, including its address, whether it's blessed. These are all things that you want to look for, but Perl can't tell you easily. You can figure them out, but it's not worth figuring them out because they're much faster here. So everyone here has seen the output of ref, right? And a stringified reference. What is the stringified objects give you a lot of information. They tell you everything about an object. And that's the problem. You don't want to know everything about something. You want to know its address. You want to know whether it's blessed. You want to know its base type without having to parse a bunch of string to find out what's inside. So these are a great example of less is more. You get only what you need and only what you ask for. So you've seen stringified with the Foobar-ARRAY and an address. If you want to know what package something's blessed into, you can regex off the name equals on the front. But do you really want to do that every time? So the first one is blessed. And if anyone knows where this came from, there's an interesting history. But blessed returns a class or endf, nothing more. So this is how you check whether you're dealing with an object. It allows you to generate. You can test a lot of times, because in Perl you can dispatch into a subroutine without an object. If there are places where you've got generic interfaces that people might test the wrong way, or you're writing your own internal tests. Was anyone here for the testing workshop? Yeah. These are great for the question, did the person come here through the right channel? If I've got a test and the test says, is the thing I get back from new an object? Because you can't imagine how many times people forgot to bless something on the way out of a constructor. This allows you to check that. You can also, this is a method, people say that this is for cloning, it's not. What it allows you to do is use one object as a prototype for another object, which is great if you're in a situation where you're making a generic factory class and you have an object, you don't know what type it is because you're a factory. It's not your job to know what type it is. You just want to make more of them. So if you bless it into bless $proto or the prototype, someone can call object of type that I know what it is points to new, and there's no harm. Otherwise, if you just bless it into the first item on the stack, what you're going to bless it into is a class named array, 0x8, which is probably not what you wanted to do. Another great thing is if you're writing tests, check whether the thing is blessed before you validate whether it can do a method. Because calling can on a simple scalar is an error, not a very good test. Your test itself is going to blow up rather than telling you, I can't do this. The other problem is that ref doesn't, if you use ref by itself, you won't get the base type of a blessed reference. You'll get its package name. If you're parsing or processing general structures, you have to walk down a hash or an array tree or something. Using ref isn't going to tell you how to walk into the next level of structure. So if you're writing something that does generic comparisons, again, the compare deeply in the test deep module, it has to use this because it doesn't know what it's going to be passed. So you can use ref type to say, is the next thing I'm looking at an array, is it a hash, what? These work beautifully with switches. Whether or not you like switches and smart matches, it really does. This is a case of where the return is simple enough that smart matching does the right thing. The switches work beautifully with this. And you can deal with data at that point. This is also really nice if you're dealing with XML simple, which isn't. And is anyone here, do you deal with XML simple? Do you always get exactly the structure you expect out of XML simple the first time? Maybe not. Well, at least this way you can tell what you're getting as you walk down it. This is great for validating the return structures in XML simple. This is also great if you're passing a lot of data around with XML and you have different edge cases that you want to make sure the people upstream did the proper thing with the defaults for XML simple. You can write tests with generic data things and say, if I go to this key, is it an array ref? If not, blow up because the person didn't do it right. Sorry, I can't parse this. On the other side, if you're getting this kind of generic data, and has anyone ever had clients who change the data without telling us? Yeah, and maybe they blew up XML simple in the process. Maybe they mistyped their tags, who knows? But I can go through, I can validate this stuff when I'm processing the data, and this is pretty declarative. If anyone who looks at this can pretty much tell what it is. Smart matching. A lot of times you'll want to use smart matching, but whether or not we agree with it, if you're going to use an object in a smart match, it has to have an overloaded smart match operator, which makes a little bit of sense because the things like the long integers, which are stored as hashes, if you smart match an integer to a long int, you'd expect an integer comparison. Without the overload, what you're doing is comparing an integer to the keys of a hash. So the overloading helps, but when you're testing, people occasionally forget to overload things. So this allows you double tilde quoted, if all your objects are supposed to have quoted overloading or if you need it. If you check for blessed before you check for can, your own test won't blow up by accidentally calling can on a non-object. Also works with version or any other validation for methods. Inside-out classes. Do people understand what these are? People seeing these things? The first place they were used actually was DBI. Tim Bunce invented this notion. Everyone ever looked at a DBI object? What is it? An empty hash. If you're in the Perl debugger and you do an X of $dbh or a statement handle, all you will ever see is an empty hash. And people used to freak out. You like try to display it, and you'd never see anything. No matter what you store in it, you'd never see anything. It's a tied hash. What he does is he takes the address of the variable, and he uses that as a key into another hash to store his private data. So you can't play with it, only he can. So if you take a stringified ref, the original way of writing these before refadder was you'd put the object into the hash, which gives you a stringified object, which contains the address, so it's unique. The problem is, if you accidentally do that before you've blessed the object, you can't access it again, because now the stringified version of it has got the key, the bless equals. If you re-bless it, if you create a generic object and you pass it up a constructor chain and something re-blesses it, you'll also lose the data because the thing in front of the equal sign, the package name will change. So this didn't work too well until you use refadder, because then all you're using is the 0x mumble. That's unique, and it can't change over the life cycle of the variable. Now you can store whatever data you want to and associate it with an object for that object's lifetime. So this is the simplest version without a lot of extra testing for an inside-out class. You can store anything you want to, and it doesn't have to be a blessed reference. If you get data from XML simple, and it's simply data, and as you're parsing it, you want to store something outside of it that stores validation, stores extra stuff that you pulled out of the database for that portion of it, you can take any reference you like and store whatever you want to about it using refadder, and you'll be safe as long as that thing exists. The catch is, down here in destroy land, because this data is outside of the object, you have to make sure to clean it out yourself. And that's why the destroy uses this with the refadder, because otherwise you're going to have a memory leak, because you're going to be saving things about everything, and it won't go away when things go out of scope. But this also saved people from having to tie all the variables, because you can do a lot of the same stuff with a tied variable, but it's a lot simpler this way. Another thing you get in scalar references is the ability to weaken a reference. Do people here, you've seen how Perl manages variables with reference counting? Does reference counting make sense? Not a lot of hands. What happens is, in Perl, when you create something, it exists. Just because you're such a nice person, I'll give you a reference count of 1 for anything you create. Lexical variables. You create it with a my. At the end of whatever block it's in, if nothing else is using that variable, the reference count goes to 0, the storage is returned to the heap. If I take something and store it, let's say I push it onto an array. The array has a reference, the variable has a reference. Reference count goes to 2, the my portion of it goes out of scope, and you've got an anonymous thing on an array, but it still has a reference count of 1. Reference counting is simple, it's fast. A lot of people don't like it for garbage collection for one reason, though. It's possible to have a self-referencing item. So here's an example. The first one, if I set $A to $A, the reference to $A ups the reference count of A. Because it's stored in A exists, and it refers to itself. Reference count of 2. If A goes out of scope, it still has a reference count of 1 because it's storing itself. That is a memory leak. That's probably an error. The line below it, though, I do a lot of work with linked lists. A doubly linked list, or a circular linked list, will never go out of scope. Because something always refers to something, the reference counts are always 1, and Perl will never clear out the variables. Is this making sense to anybody? Well, here's a solution to it. We saw this yesterday in one of the lightning talks with weaken. What I can say is, let me create a reference that doesn't keep the variable alive. I decrement the reference count. So this reference won't keep the variable alive. It's just a bucket that remembers where something came from. So if you're used to the Unix file system, it's like a symbolic link. I can have a symbolic link to no place. The symlink won't keep a file alive on the file system. It just tells me where to go to find it. Same thing here. If I weaken the backlink and then store the backlink in a variable, the reference count on $A on the second line is 1. A will go out of scope. I can clean up my linked list. If I delete a node out of the list, it'll go away nicely. I can still find it, because I can still go to A points to 1 all the time. But if A's gone out of scope and I have another pointer to something and I walk down it, that backlink will be undef if the variable A has gone out of scope or if whatever holds it alive has gone out of scope.
Is there a way to find out the actual reference count?
You can't find the reference count, but there is an isWeak, which allows you to check if a reference is weak. And if it's not isWeak, you know that the reference count is at least that many. If you wanted to find the reference count, you'd have to play around in XS. Generally, you don't really care what the reference count is. You just care that the thing is alive. 1 or more is good enough. It's unless you're dealing in Perl guts itself and questioning whether to return something to the heap. What you'd want to check is, let's say you're writing a test, and you want to check whether or not the references you've got to something are going to keep it alive accidentally because you've had problems with memory leaks. There is a function called isWeak that's provided by scalar utils. And you'd walk down all the references that you know you keep to something and you check that they're all weak. So that there's only one not isWeak copy. So in a linked list, you check that the link going forward is a strong link, and you check that the link inside the thing is weak. And if you've done that, you've done everything you can. It is. You can't. It's just the way references. This isn't C. You don't have pointers. You have references. They're going to be counted. Another thing most people have seen. We've all done this once. Check for a number, right? Up \D $. Realize that is a bad idea for a number of reasons. One is it's slow. Even with the newest regex engine, regexes are not that fast. The other thing is, digits are fine, but then you have 0E0, which is a number. Between exponents, octal, hex, write a reg. Has anyone ever seen the regex for all the numbers? It's in the regular expressions book. It wraps 3 times on the page between floating and double and int and hex and exponents and binary. Don't forget binary. So you got little letters that you got to do. Oh man, what a mess. Because then if you know it's binary, you've got to only check for zeros and ones. Perl has a function inside of itself called looks like number. Guess what it does? And it's got all of this. This is what Perl uses itself when you want to print something and it has to be nullified, or if you're doing arithmetic and Perl has to decide whether or not the next set of characters should be treated numerically. Perl knows if it looks like a number. This taps right into it. It is fast, and it knows everything about numbers that Perl knows about numbers. So you can have, the simplest case is you get an if block.
It also knows that the string INF is infinity, which can be really helpful.
If you're,
And it can be really very
yeah. Well, there's the whole issue also of 0 but true, which is a number. So 0 but true will fail the \d test, but it will be treated numerically by Perl. So if you really want to check whether or not the next thing you're looking at is something that Perl will treat in the opcodes like a number, use looks like number, and you'll always get it right. And if the Perl standard evolves, you're not going to be changing the regex in 85 places. You're just going to get it right the first time. Another thing you can get, and I haven't gone through all of the mins, but in list handling, if you look at something on the list and it looks like a number, you're probably going to compute the minimum differently than if it were a string. You're going to want to use a numeric sort instead of an alphabetic sort. You can now do that with one line. If you're trying to input something you think is numeric, validate the user input. Either it looks like a number, or it's not a number. The other great thing about this, if you've got to read the regex from hell and decide what it does, and you're looking at somebody else's code, and they wrote the regex differently from you, might you be wrong about whether it works? I would. If you see the phrase, looks like number, do you kind of think what it does? It's pretty declarative. You can understand what you're looking at, and there's something to be said for that. Another thing we get into, I don't like prototypes, but for people who do, one of the downsides in Perl is you cannot prototype an anonymous subroutine, because there's no declaration to prototype it with. There's no place to put the dollars and @ So one of the things you get in the scalar utils is set prototype. One use for that is if you want to create an anonymous subroutine that handles a block properly. You've all seen map, grep, the rest of these things, where you just have curly braces that do something, and then you've got the arguments. To do that, you require a prototype, because it has to know that that block should be treated like a scalar and not executed to get a result. So if you want to return closures, if you want a factory for handlers in methods, which can be a really handy thing to have, then this is the way to add the prototypes after you've constructed the anonymous subroutine. There are times when I use blessed subroutines, and I pass the object around, and the object knows how to tell when it's supposed to be executed. And you can have an object that takes a block and executes it. Another use for this is you can have misguided cases where people prototype a subroutine with $$ because they think they want 2 items. And now you can never call it by just passing arguments down with @_. You can't do a go to ampersand, because what's on the stack is an array and it wants 2 scalars. So this allows you to unset the prototype if you're wrapping something. If you want to overload somebody's method and they're driving you nuts because their prototype breaks the way you call it, this isn't really, methods dodge that, but if you've got a subroutine, this will allow you to wrap somebody else's thing with a saner or appropriate subroutine for your environment. I shouldn't say that. I've never tried to do this on core global anything, but it should work. I mean, it's the same data structure. What you have to do is there are actually still some core global thingies that have $$ prototypes, and you can't call them with thing of @ underscore and just have them do the right thing. So yeah, I think this actually might allow you to. At the very worst, what you'd have to do is strip out core global something, stick your own subroutine into it that's got, @ as the prototype, and then use that to call the inner thing. Bipolar variables. Yes, we have psychologically challenged variables in Perl. One of the things you want to do, and the classic example of this is a discog program. Discog programs walk down the file system and ask which things take up space. And sometimes you want to print it out as a number, sometimes you want to print it out as a string. So dual-var does that for you. You create it with a number and a string. If you use it in anything numeric, you get the number value out of it. If you use it for anything stringy, you get the string value out of it. You could do this in Perl with overloading, but the nice thing is that this is a lot faster, and because it's encapsulated in XS, there are very, very few ways for anyone to screw up your dual-var, where if you used a plain object, somebody could actually try to reach into it and play around with the thing. The example here. Let's say I've got a bunch of usage and strings, and I want to sort things by number and then print them. Show me all the portions of the file system that are more than 80% full. I can have one thing in file find that creates dual vars for usage and name of thing. I can select them with a greater than and print out the names. That's what this does, but I don't have to have all the if blocks and points to 0 and points to 1 and the rest of it. I just have a nice encapsulated object that does the right thing. They're also nice if you're dealing with process tables. You can have the process ID and the name of the command and just encapsulate that in one thing. They're nice if there are times when you end up storing things in hashes because you want to keep track of a name and a value, and hash points to value just seems like the easiest way. But hashes are horribly inefficient, and you find if you have an array of dual vars, you can usually get the same thing done. In fact, in Perl 6, hashes are lists of pairings. This is an example of an underlying pairing that you can store that way. Anyway, there are a few things. Open handle is kind of nice. Anyone here deal with sockets? Anyone ever had a socket that was closed when you tried to read on it? Check! It'll tell you. You'll know now. It's also nice if you're dealing with input from terminals. Anyone have a terminal that went away? Right. Nice, simple, is open. There's vstring. If you have something like v5.16, whatever, you have to treat vstrings separately in some contexts. They don't really behave numerically all the time. You can check if something is a vstring, which is really neat when you're writing tests, regression tests or utility tests for your own modules. You can validate whether the version is a vstring and whack the guys that don't use them because they are a much better way nowadays. Tainted, you'll never guess what that tells you. But it's really nice, again, even if you don't use tainted in your code, it is wonderful in tests. Did all the nice people who read the input untaint it properly? This is also neat that you can do tainted checks. A lot of times it's good if you put your sanity checks into one place so that you can maintain them outside of the bulk of your code. At that point, you can have the thing that does the untainting validate whether it's getting tainted data and fail if the data coming in is untainted because it may screw up your internal taint checks. Is read-only, checks for read-only values. You can create those in Perl. They're constants, or if you assign a reference to a constant to a glob, you can install a constant, pi, whatever. You don't want to try and modify those because you'll blow up. Again, these are really nice for tests. You can have a test that checks for is read-only on what you thought was an array of constants that you're passing around to different things that aren't supposed to modify them. Managing lists. List util. Most of these are obvious. I'm not going to describe min, max, min string, you can kind of figure out what they do. Sum. Can anyone not figure out what sum does? Fine, we're done with that one. Minster and Maxter do what you expect. They're stringy compare. Instead of using a less than greater than, they use an LTGT to find the minimum string. Shuffle randomizes a list. The other way to do this is to assign things to a hash and take the keys back out. That is slow, it is bulky, and it's error prone because the keys will come back in deterministic ways. There are times for security when you can't put things in the same order every time, or for testing. If you want to test that people validate things without just taking them blindly by order, you can shuffle them, and it's very fast. Yes, well, it's pseudo-random. Nothing on the machine is truly random. Yes. Again, you could do this yourself by doing a sort and pairing the thing with a random number, sorting it, and then spitting it out, but it will be a lot faster using shuffle. Now, the remainder of what I'll show you, these things, they could be written in pure Perl. There's none of these you can't do with $A and $B or whatever. First thing is speed. They are fast. XS is quick. But another thing, too, the interfaces for what I'll show you, they just work. Getting the prototypes and the variables and making sure there are no external side effects is not easy to do. You can do it, but you're going to waste a lot of time on something that's very fast and already done for you. The other great thing about XS is it encapsulates the data. You're not going to accidentally have side effects where people reach into your code or play around with what's in it because they can't. They can't easily. Anyone that can screw around with the guts of these things is writing their own excess, and you can't stop them. They'll use Padwalker and get on the inside anyway. But for the 99% of it, this is a really good way to make sure that things just work. The other thing is there's really good documentation for these things. Does anyone really enjoy writing pod? I mean, you just can't wait to get up in the morning and put little equal signs and do all. Okay, you guys forget about it. The rest of us, these are documented already. Why spend your life describing how to compute this stuff when someone else has already written really good instructions with examples that work? People forget about that. Yeah, I could do all this in pure Perl, but then I'd have to document it. You know, we're programmers. Pod is a very good thing, but if there's that much less documentation you have to write because someone's done it really, really well, go to CPAN. Anyway. Oops, I slipped aside. First thing, why bother? Oops, I lost a slide. There was a really good pun on there. Damn. Second thing is first. Anyway. First thing, why bother? The second thing, oh, God. Well, first, I'm sorry about that. The bloody slide got, oh, blast it. Anyway, what first looks a lot like grep. It takes in, you have grep with a block and a $_ and for every place the block returns true, you get the original value of what was fed into the block. Unlike map, which you get the modified value, all you get are things that made the block turn true. The difference between first and grep, two important differences. First returns a scalar, and it stops after the first time it finds something. So if you grep something, the classic thing is you do a grep, and you assign a variable in parens to the list, but after you've done the assignment, you're going to keep processing the list. If the list isn't trivial, you're going to waste a lot of time processing a lot of stuff you will never use, and Perl doesn't know that you don't want to use it, so it keeps going. So first is faster. It's also syntactically easier because if you leave the parens off of the variable, you don't get a count of the number of the things that matched, you get the first item. And there's something to be said for simpler syntax. Now, one of the things that happened when smart matches came out is they can be faster than first at finding whether something is true. One of the things you use for first is this scalar on a list? Obvious use of it. So people compared first to smart match and said, smart matches are faster than first. We don't need first anymore. Wrong. Smart matches, whether you like them or not, return a Boolean. The most you can get out is quote, quote, or 1. First will actually give you the value that matched, so that I can use the value for something else. So, bing, now we get to this thing. A lot of times, the smart match operator, though, is great because it can do generic matching. Whether it gets confusing or not, Perl always gives you enough rope to shoot yourself. So, smart matches are one more case. If you want simplicity, use C. But the one thing you get a lot of times is, let's see, smart matching is declarative. So let's say one of the classic things we've all written is a command line checker. Did you give me mutually exclusive items on the command line? And you've seen the if this and that, if this and this, if this and something else. And then you have to modify the command line and you blow the if block because you forgot to add one into the if block. Or you typo the if block. Or you drop something out. This will check for everything in one step because you can say, look, here are the things that if I find them together, we've blown it. So the first time I find one of these pairings, or triples or quadruples, you don't care, that all exist in the argument hash, it's botched. Stop. Print out what the person blew and die. We're done. Count the curly braces or not, it's what, 6 lines of code, and it's declarative. I could put these combinations outside the program in a flat file of bad options, and people don't have to muck around in the code to change what we consider mutually exclusive switches. So you can do a lot of things with smart match and the first operator that are really fast and do what you need. Returning a scalar. I actually got to go faster because I've been running out. One thing I use a lot, they will ask questions, did I see a value by looking for hash keys? That is slow. You have to convert the thing to a hash key, you have to numerify it, and then you're walking down a list anyway to deal with collision chains. For really, really huge lists where it's all collision chain city anyway, or really small lists where computing the hash key values is expensive, you might find that first on an array is faster than hash lookups. So if the only thing you're asking is, have I seen this value in this session? First on an array may actually be faster than doing hash lookups on everything. If you have lists of regexes, I can find the first regular expression that matched my data very quickly. That allows me to, without a lot of if logic, I can validate, did I get a usable line on the input? I can say first of things that match usable input or die. I can iterate lists of objects and find the first object that knows how to handle the data. In Perl 6, this is kind of cute, or even in Perl 5, Brian Foy wrote a really good article on how to use the named captures to parse fairly complicated data within the regex. Well, I can say, find me the first regex that successfully parses the data, and stop. What's cute about this, too, is, hang on, my found is, yeah, so if I have a bunch of known structures, again, this is great for validating XML simple. If I think I'm supposed to get at least this many keys depending on what kind of data that I read, and I have an array that has array refs with the minimum number of keys it takes to make a well-formed record, I can say walk down it and find me the first collection of keys that make me believe I've got enough data to process. No if logic. Now, another cute thing you can do, and this will be the last thing I show on first, I think, but a lot of times you'll have something where you want to segregate data based on a regular expression or a subroutine execution. don't know if anyone's, but you're getting a whole lot of log entries. You want to either discard them or bucket them by which service, or bucket them by, what time of day, bucket them by whether they were errors or not. If I have a bunch of regular expressions, I can take the reference address of the regular expression and use that to store data that I got from that expression. So I can have a list of filters. For each line of input, I find the first filter that matches this row and stop. At that point, I can use the reference address to store the data, to get data out of it, or I can even push onto a list based on the ref adder, and I can segregate all my records based on the regular expression with no if logic. I find it, I use it, I go on to the next record. It's a lot less code, and then you don't have the if logic is usually where you end up typoing something that blows the whole thing up. Again, you can use the same idea. I can find the first thing that matches. If I have an inside-out structure, I can have anonymous subroutines keyed to the regular expression. I can use the ref adder of the expression to find the handler. I can dispatch the handler if the regular expression matches. Reduce. Minimum, maximum, they can all be done in terms of reduce. What it does is it takes A and B, your first two items, compares them, the result goes in A, and then it gets the next item. So this shows you what min and max are just reduces with pre-assigned blocks. If you want to get the sum of x squared, you can take 0 in a list, and you add in the square of the next number. So this is actually really nice for moving averages even, because you can push it onto a list. There's a lot you can do in there, but again, this is something that if you take the time to read up on it, and the pod's got good examples, it works. The last thing is there's list more utils. Now that I've shown you all of this, no, that's not all of it. Anytime you find that you're thinking about playing with array indexes and adding one to them to do something, don't bother. It's probably in here. This is a perfect example of a kitchen sink. These are, you can find it. You can find all of something, any of something. If none of the things on this list match what the block returns, if any one of them does, if not all of them, you can ask if the thing is true. I'll show you a few of these that I use. First, we've gone over that a lot. Ever want to find the last thing that matches? It's something I have to deal with. Find me the last piece of input that was valid if you're trying to validate a whole record or something. Well, that requires reversing the list if you use first. Except that list more utils gives you last. It will compare everything. It'll remember the last thing that matched, and it will give you the last one. You can get the first index, you can get the last index. And those will give you the I and the index number of the item on the array that did the match. Before and after, do slicing based on first index to get you an item that happened before the first time something matched. So if you have an error, you can find the last good piece of input. These are also nice in testing. There's an any operator. First, the difference between first and any is that first gives you the value put into the block that left the block true. Any gives you the result of the block that was true. So first will tell you the first item on a list that was defined. Any will give you the value of defined that was on the list. That's one way to do it. If any of these is true. But again, there are times when what you want is a more mappish behavior where you want to see what was the value that made the block true. So any is like an aborting version of map. The first time the map outputs a true value, you get the true value. So if you're running a subroutine and you want to see, show me the first thing that the subroutine was true for, you'll get the value. But a lot of times, it depends on what you're using it for, but you can get either way because you got map. This is Perl. There's more than one way to do it, and this will give you all the ways there are. Unique was one thing that was left out. Why not do, well, you put things into a hash, you can get the unique out. But unique is interesting because it preserves order. Every time it sees something, it just keeps skipping the rest of them, so it doesn't sort your data. If you want to find a unique list of error messages, and you want to keep the error messages pretty much in their original order, because you're trying to find where in a log did the errors happen. Were there warnings first? Were there not warnings first? You can uniquify them and see, oh yeah, there were no warnings before this error. And doing this in pure Perl is slow. Relative locations, they're insert after and insert before. Insert after is really neat if you're trying to segment data, because you can find the first thing, if you find the first thing that matches whatever you're doing, and you want to say, okay, I found this, I now know where the end of a block in my data is, the insert after will find your thing and then put a value after it, if that made any sense. Insert before does kind of what you'd think it would. Map. One of the downsides to map and grep and sort. People don't realize if you modify $A and B in a sort, you will be mucking around with your input data. What the apply function does is it's like map, but it localizes $_ so that it doesn't affect. So you're dealing with the values on your list. You are not dealing with references to them. It's a little bit slower because it copies things, but for a lot of cases, people have, I know, you uppercase whatever it is, you regex it to compare it a certain way, and oh yeah, I've just modified all my input. You may want that, but usually you don't. So apply doesn't have side effects. Merging lists. You can get pairwise, you can get n at a time, so you can get things out of this where if you have two lists and you want to get the first item on each list and then the second item on each, because you're comparing the two lists, in pure Perl you either have to use indexes, which are slow, or you have to destroy the list by shifting things off. Or you can use pairwise, which given to list returns an iterator, and each time you call the iterator, it gives you the next two things on a list, and because it's written in C, it can have pointers, so it just advances them. There's also, let's see, another thing, because these use prototypes. In order to pass two arrays in and keep them separate, you have to use prototypes to convert the @ signs basically to \@ signs when it's read. You have to use arrays with these. If you use array refs, you're going to blow it up. You can iterate separate lists. You can get each thing out of an array. So if you give a list of arrays, however long it is, you'll get back one thing that each time you call it gives you the next thing on each list, or undef if there's nothing left there. So yeah, there's a lot of stuff we've all done with indexes that, did the index run out? Did it do this? It's all done in one step. No, it'll give you if you give it arrays A, B, and C on the way in, each time you call this, you'll get an A and a B and a C. So you'll get the 0th item on each. It's doing a vertical slice through all three arrays, which again, it's really nice for processing log files, for comparative data, for a lot of stuff you might, if you didn't want to use PIDL just to walk down a bunch of multiplies, you could use this. Last two things are Pod is your friend. These have got lots of documentation in it, and there are examples of how to use them, why to use them. List more utils. Take the time to read through the pod, because there's more in here than anyone's going to stay awake with me describing. So the real short of it then is these, and a lot of like them on CPAD, have been around for a long time. It's a good thing about Perl. This XS code, which really deals with the guts of Perl, has been around this long, and it still works. That's pretty good. These guys haven't torn their hair out maintaining it. A lot of people complain, oh, Perl doesn't do this, it hasn't evolved fast enough. But the guts of Perl have managed to keep all of the stuff in cpan alive for this long. The stuff isn't moldy, it's still relevant. So, smart matches are really nice with first. They're really nice with a lot of these list operators. And anytime you think about doing index math, don't. You probably can do it easier with these and faster and with a lot less code. So, yeah, the truly lazy wheel is the one we don't have to reinvent every time you do something. And that was it.
Thank you.
Is anyone alive? Yeah, there.